This is AQA A-level chemistry and it's the year 12 topic bonding. This is part 2 of the bonding topic, and in this video we're going to be focusing on some of the GCSE skills that you will have already developed surrounding covalent bonding. As always, I'm going to recommend that you pause as you go, have a go at the activities when they come up, and then you can review your answers and see what's gone well and what you might need to work a little bit more on. So we need to know what a covalent bond is. We also need to know what a coordinate bond is, which is a new introduction for A-level chemistry. And we're going to look at the properties of covalently bonded molecules. The first thing I want to look at, though, is dot-cross diagrams. And this is a representation of covalent bond structures. It's really important on its own to get marks, but it's also going to be incredibly important when we move on to shapes of molecules later within this topic. Now, whenever you're doing this, I've got a set of rules that I recommend that you go through. And that's, in the first instance, you pick either the central atom within your molecule, or if it's a pair like we have here with the two H's, you pick one of them. And then you go through these rules and you ask yourself the questions. Hydrogen, what group is it in? Well, hydrogen is not technically group 1, but it does have one electron in its outer shell. So that answers number 2. So how many does it need to gain to get a full outer shell? In this case, it needs to gain 1 because the principal energy level holds 2 electrons. So for every electron that you need to gain, you need to put 1 in. So you need 1 covalent bond. And the final thing I look at is the fact that there is 1 shared area between the H's. So I know that the hydrogen is going to put 1 electron in. This hydrogen is going to put 1 electron in. That's 1 covalent bond. Both of the hydrogens now have 2 electrons in their outer shell. So what we're going to do is move on and look at some further examples of this. So let's try oxygen, O2. Now, once again, we are working our way through the rules. We don't have a central atom here, so we pick one of the oxygens. Oxygen is in group 6, and that means it has 6 electrons in its outer shell. So to get a full outer shell, it needs to gain 2 electrons. And if I'm going to gain 2 electrons, I need to also put 2 electrons in. So I'm going to form 2 covalent bonds. Now, within the structure of oxygen, there is 1 shared area. So I've got 1 shared area and I need 2 covalent bonds. So I put them both in the centre. I've then got to be very, very careful. Oxygen has 6, 2 have gone in the centre. There's my other 2, 4. I've now got 8 electrons around this oxygen, 8 electrons around this oxygen. They both have a full outer shell. Diagram done. Next example, water. So in water, we're picking the atom at the centre. There's only 1 oxygen and there's 2 hydrogens. So we're going to do this with oxygen. Oxygen is in group 6. So it has 6 electrons in its outer shell. So it needs to gain 2. So it will need to form 2 covalent bonds. And when I draw the structure out, you can see there are 2 shared areas. 1 between this O and H and 1 between this O and H. So if I've got 2 shared areas and 2 bonds, I'm going to put 1 in each shared area. I then have 4 remaining to go on the oxygen, and I can see this hydrogen has 2 electrons, this hydrogen has 2 electrons, and the oxygen has 2, 4, 6, 8 electrons around it. Next example, methane. Okay, so carbon is at the centre. So carbon is in group 4. It has 4 electrons in its outer shell. So it needs to gain 4, so it will form 4 covalent bonds. And we can see in the diagram that's drawn out that we have got 4 shared areas. So carbon puts 1 into here, 1 into here, 1 into here, 1 into here. Each hydrogen puts 1 back as well. So the hydrogens have now got 2 outer electrons, full outer energy level. Carbon has 2, 4, 6, 8 outer electrons, full outer energy level. Next example to try is ammonia. So ammonia, I've got my central nitrogen, I've got my 3 hydrogens around it. Very quickly going through the questions, nitrogen is in group 5, so it has 5 electrons in its outer shell, so it needs to gain 3 electrons, which means it needs to form 3 bonds, and there are 3 shared areas. So I put my pairs in the NH bonds, each hydrogen putting 1 electron in 2. Nitrogen is in group 5, and I've used 3 of those electrons so far. That means I have 2 left. Each hydrogen now has 2 electrons, 2 electrons, 2 electrons in its outer energy level. Nitrogen now has 2, 4, 6, 8. And we're done. Next example, nitrogen, N2. So let's draw it out. You can see that there's an N bonded to another N. Nitrogen is in group 5, which means it has 5 electrons in its outer shell, which means it needs to gain 3 to get a full outer shell, which means it needs to form 3 covalent bonds. But there's only 1 shared area. So all 3 of those covalent bonds go in the same shared area. It's a triple bond. The nitrogens have each got 2 electrons left to go on their outer shell. This nitrogen has got 2, 4, 6, 8 electrons on the outer shell. This nitrogen, 2, 4, 6, 8 electrons on the outer shell. And let's take a look at carbon dioxide. So I've got 1 carbon and 2 oxygens, so the carbon goes in the centre. Carbon is in group 4, which means it has 4 electrons in its outer shell, which means it needs to gain 4 electrons, so it will form 4 covalent bonds, and there are 2 shared areas. So I put 2 pairs in each shared area. I then need to work out how many are left. Carbon, I've used all 4. Oxygen, I've actually used 1, 2 electrons. So I've got 4 more to go onto each oxygen, and there we have the final structure. So let's take a look at coordinate bonding to finish this section of the topic. We know that a covalent bond is a shared pair of electrons. I want you to take a look very carefully at the diagram here and work out which of these bonds is different. Why is it different? And what makes it a coordinate bond? Well, the fact we're using dots and crosses is really quite useful here. We know that dot electrons and cross electrons are identical. They're simply representing the fact they come from different places. But this then stands out. I've got dot cross, dot cross, dot cross. Here I've got cross cross. Now, if I took that H plus away, those crosses would still be there on the N. It is a covalent bond. However, both of the electrons have come from the same nitrogen atom. So for that reason, we call it a coordinate bond. A coordinate bond, to keep it really simple, is a covalent bond where both electrons are provided by the same atom. So let's look at some examples. Let's look at how we could build a coordinate bond between a water molecule and a hydrogen ion. Well, if I draw out their electron configurations, we've already seen water. Water looks like this. And the hydrogen, actually an H plus ion, has no electrons. It's essentially a proton only. But there is still space for 2 electrons in its outermost shell. So what will it look like if I put those together? Well, if we follow the same principles that we saw with the ammonium ion, with ammonia and the H+, I have got my water that looks very similar to what I drew, but my hydrogen ion has combined using 2 of the electrons on oxygen's outer shell. So we've got a coordinate bond here, which I've done in red. Final thing that I'm going to show you before we finish this video is how we represent a coordinate bond. A covalent bond is simply a line. A double bond is 2 lines. A triple bond is 3 lines. But a coordinate bond includes an arrowhead. And the arrowhead points in the direction that the electrons have been donated for sharing. So because both of the electrons in the OH bond here come from the oxygen, we see that the oxygen has donated both of the electrons to go into the bond. And then finally, I've got the brackets around it, and the whole of this now is a positive ion. It's actually a hydroxonium ion. You'll learn more about those in year 13. That takes us to the end of this section. Thank you for listening. Goodbye.